Hello everyone, welcome to AI Sciences. My name is Shazeb Hamid and today we are going to develop a human activity recognition mechanism with the help of Python. The main libraries that we are going to use is Pandas and NumPy, and I have already downloaded a dataset. We are going to work on that. So first thing first, let's import the libraries. So first library is Pandas. So let's write import Pandas as PD. And the second library is NumPy. So let's write import NumPy as NP, and let's run this, and later let's input both of the datasets. So the first dataset will be called train, and it will be pd.read_csv, and the name of the dataset that I have already saved is train-1.csv. And let's do this, and let's now write test. So test is equal to pd.read_csv, and in here I'm going to write test_csv. So this should be in inverted commas. So let's put one here and let's put one here as well. And now let's keep going. What is the next step? The next step is to actually take a look at these. So this is the train, right? These are all the columns that we have, and this is it. And at the end we have the activity that this is standing and these are walking upstairs and these things like that, right? And in the same way, when we look at the test, we can actually see at the end that there is a activity part just like the one previous, and all the columns that are available to us are the same, right? So now what do we want to do? We want to actually combine both of these data sets. So the first thing that I am going to do is I am going to write train data is equal to train, right? So that we can later differentiate between both of them, and test data is equal to test. After that, what I'm going to do is I'm going to concatenate both of them, and let's name the variable both, and then I'll write both is equal to pd.concat, and in this I'm going to write train and test both of them. So let's write train comma test, and in here let's write axis is equal to 0, right? And after that let's actually write dot reset underscore index, so that we can change the index and drop the previous as well. So to drop the previous one, we will write drop is equal to true with a big T. Sorry, this is not needed. Let's move on. And what is the next step? The next step is actually to take a new column in this both variable, right? So that column will be subject, and here we are going to write hash in a hash in here, and after that I'm going to write plus, and here I'm going to add both subject into this, right? And we are just entering hash with everything right in the subject, and then I'll write subject, and later what we can do is we can write that we want to save it as string. So for that we will use as type variable, and in this I'm going to write string. Now let's see the shape of train and test, both of them, after this. So there we go, this is it. Now let's see the shapes. Let's actually put a few cells in this. Now if I write train dot shape, So this is the shape of my train data set, and if I write test.shape, so this is the shape of my test data set. As you can see, this part is the same, and in this part we have more entries, and in this test we have lower entries, right? And in the same way, what we can do is we can actually see both, and both will be just a combination of this and this, right? So if you see this, if you add 7352 and 2947, you will get these many rows, right? So it means we have been able to combine both of them. So what is the next part? The next part is actually to write that data will be equal to both, and then data in both, right? After that, activity will be equal to, so these are all the columns that are available, right? So activity will be equal to both, and there is a column by the name activity, so we will write activity here. After that, I'm going to write subject, and subject can be actually seen from here as well, because it is one of the last columns, right? So this is the column subject, and in this it is just written that this is subject 1, this is subject 1, this is subject 24, all of these things, right? So these hashes were not present before, and we added them right here in this column, right? So this is what we did so far. Anyways, so subject can just be something like both subject, and these are all the columns. Let's run this, and after that let's make a copy of train. It is actually better to always make copies. So both dot copy is equal to train, and in this let's delete all of these columns. So to drop these columns, I'll write train dot drop. These are very easy commands, and I believe if you know a little bit of Python, you can understand everything that I'm saying, right? Okay, so first one is data, and the second one is subject, and the third one is activity. So there we go, and at the end we are going to write x is equal to 1. Okay, so it is saying that function object has no attribute drop. Actually this copy is a function, not a simple variable. Let's run this again. Now we have been able to get the train. If after this you look at the train, then you will see that in train there will be no subject available, right? And of course all two of them will not be available as well. So what is the next step? The next step is actually to perform dimensionality reduction, right, on the train data set. So for that I'm going to use PCA, which is available in sklearn. So let's do that. Let's write from sklearn dot decomposition and import PCA, and after that let's write small PCA is equal to PCA, and in this I'm going to write n underscore components is equal to 0.9, and other than that random underscore state is equal to 0. And at the end I am going to try to fit into this, right? So for that train is equal to PCA dot fit underscore transform, and we will put in train in this, and we will get the train out of that as well. Okay, so now that we have done this, the next step is to actually first let's see this. So this is what is happening to our train data set after dimensionality reduction, right? And what is the next step? The next step is actually to see the division of x train, x test, y train and y test. So let's do that now. For doing that, I'll write from sklearn dot model underscore selection import train underscore test underscore split, and in this I am going to write x train and later I am going to write x test, and then I am going to write y train, and then I'm going to write y test, right? So after writing all of them, after writing all of them, what should I do? I should write train test split. So let's write train test underscore split, and in this split I am going to enter the train, right? Of course, that is the dataset that we want to split right now. And after that I am going to say that on the basis of activity we want to check that, right? That what is the activity, so that will be the end game, right? Or the output you can say. And let's say that the test size will be equal to 0.2 here. Okay, so my num lock is off. Let me go back. So 0.2 here, and then random state. What do we want to do with that? So random state is equal to 0, and let's get down with this. Okay, so after that, what is the next step? The next step is actually to tell what are the things that we are going to see. So first thing is we will select the number of folds. So I have selected the folds to be 10. So number of folds is 10, and later we'll have to select the seed as well, which is 0, and scoring should be equal to accuracy here, right? And later we will write results is equal to flower bracket, which is empty, and in the same way accuracy is equal to flower bracket, which is empty. After that, what is the next step? And the next and the last step is actually to get a few of the classifiers. So the classifier that I'm going to use is k-neighbor classifier. Other than that, we also have to import things such as confusion matrix, accuracy score and classification report, right? And cross validation score as well. So let me get them one by one. So from sk, all of these are available in sklearn. So from sklearn dot neighbors neighbors import k is bigger, k neighbors classifier, and after that we have to import confusion matrix, accuracy score and classification report, which is available in matrix. So from sklearn dot matrix we will import these two things, which are confusion underscore matrix and accuracy score, as well as classification report. So classification underscore report. After that, I am going to write from sklearn dot model underscore selection import k fold, right? So I'm going to use k fold later, that's why. And other than that, let's also write cross validation score. Now that we have all of them, let's run this and let's start making the model. So here model will be equal to this k neighbor classifier. Let's copy them and paste it here, and here the algorithm will be auto algorithm. So let's write auto here, and after the algorithm I am going to write what are the number of neighbors that I am going to take, and the number of neighbors is equal to 8, and after that I am going to write p is equal to 1, and later I am going to write weights. So weights is equal to distance. So this is the model, and we can also go through the cross validation score as well. So let's do that. So which one is cross validation score? It is here, right here, right? So to calculate the cross validation score, we will input the model, this one, and other than the model we are going to input x train, y train and scoring, right? So for that I'll write x train, and then I'll write y train, and then I'll just write CV is equal to 10, which is the cross validation factor, and at the end I'm going to write scoring is equal to scoring. Okay, and after this I'm going to write that put these things in the results. So for that let's write GSCV results. GSCV is equal to underscore dot mean, and then I'm going to write standard deviation in the same way, STD, and then this, and then close the bracket and then hit enter. So after putting that in result I'm going to perform the fitting. So for that model dot fit, and I'm going to use the x train and y train into this. So after performing the fitting I am going to perform the prediction and then check the accuracy. So y predict is equal to model dot predict, and here I am going to use x test. After that I am going to write accuracy, and in the same way I'll write accuracy, and then I'll write GSCV, and in this I'm going to write accuracy underscore score, and we have already imported that, and in that we are going to put in two things. First one is y test and the second one is y predict. So y predict, so it will give us the accuracy between y test and y predict, both of them, and at the end I'm going to print out classification underscore report, and here I'm going to write y underscore test comma y underscore predict. So let's do that. Let's run this and let's see which things are working. Okay, so there we go. We can see that for laying we have a precision of 1, we have a recall of 1, F1 score is a good one, and this is the sport, right? And this is for sitting, standing, laying has the perfect precision and recall. And after that comes walking downstairs and then walking upstairs. This is the third one, right? In the same way what we can see is if we talk about average, and the average here is 95%, right? And macro average is 96%, and weighted average is 95% as well. So what does this mean? This means that it is a very good result, right? So 95-96% accuracies are more than enough for us to trust the algorithm and the model and the development of our system, right? So this is the end of this project, right? and it was a very well executed project in which you got 95% accuracy. In the same way, you can use any dataset and you can check out the accuracy of something for your dataset. So until the next video, keep watching AI Sciences.